Hello, everyone, and welcome to the only lesson for Math 2 that we're going to have for this homework assignment, all right? That's because we have a big lesson today on the distance formula. This is when we are going to finally get into a little bit of geometry instead of doing some review. Now, what we're going to do today is pretty much how can we find the distance between 2 points? What I mean by that is let's have a graph. Let's put down 2 points. How can I measure the distance between those 2 points? So here we have 4, 1, and 9, 8. And what we're going to do is we're going to use something called the distance formula, which is effectively this right here. Now, this might look like a crazy monster to you, but I promise you, it's one of those things that it looks complicated, but once you're used to it, it isn't that bad. But you have to get through that learning curves first, right? You have to actually get over that mental hurdle of getting used to this. So first off, you might be wondering, who even made this formula? How did we create it? And we used this is actually based on something called the Pythagorean theorem. A squared plus b squared equals c squared. Hopefully you all know what that is. That's used to find missing sides of right triangles. But you might be looking at this right now and think to yourself, well, where is the right triangle? All I see are 2 dots. Well, if I draw some lines right here, here we have our right triangle. And here's our A side and our B side and our C side. If you really know how the Pythagorean theorem works, you know that the longest side has to be C. And C is effectively what we're trying to find out, right? We're trying to find what's the distance between 4, 1 and 9, 8. And what do you know? That's how long C is. So why don't we go ahead and try to find out what A and B are? Those are the easier ones. Well, how can we really find out how long A is? Well, if I measure this right here, isn't this really just the distance between this point and this point? The x value here is 4, and the other one is 9. Look, 1, 2, 3, here's 4, and then 1, 2, 3, 4, 5, that's 9. And you might already be able to tell how long that distance is from 4 to 9. But for now, let's just write this as 4 to 9, 4 minus 9, whatever that distance is. Now, next, let's figure out how long B is, the height of the triangle. Well, if we start at, this is a length of, it starts at 1 right here. So 1 and then 2, 3, 4, 5, 6, 7, 8. This length right here goes from 1 to 8, or 1 minus 8, or 1 to 8 right here. So why don't we go ahead and put this down right here. A squared for this. A is squared is just going to be 4 minus 9, right? And B is going to be 1 minus 8. Technically, you could swap those around and make more sense, but I'll just keep it as it is for now. Now, here's the thing. Let's say I'm not even going to simplify this yet. Let's say I'm just going to, our goal is to find C, right? And C is not by itself. How would I get rid of this squared next to the C? What's the opposite of squaring? Isn't the opposite of squaring square rooting? Because remember, guys, if you square root something that's already being squared, it slices away and it leaves you with just C. It's the same thing as addition being the opposite of subtraction, inverse operations, and multiplication being the opposite of division. But this right here, this setup that we have, doesn't that look a little bit familiar? And in fact, that is the distance formula, where we have, one second, where we have the x2 and the minus x1. They're matching up right there. The y2 and the minus y1, that's our 1 minus 8. And this d right here, which stands for distance, that is our c right there, right? There we go. So I'm going to actually now use the distance formula to solve this, but I'm just showing you how the distance formula was created, was originally the Pythagorean theorem. But instead of doing all this extra work we did on the left side, now we can just take our formula, put the numbers in, and get our answer. So let's do our first example. X2 minus x1, we're going to put the x values in. The first x value is 4, and the second x value is 9. The order doesn't matter. You could do 9 minus 4 instead. Even though it's subtraction, because it's squaring, it ends up being the same answer. So you don't have to worry about order. You could do 4 minus 9 or 9 minus 4. You're just putting in the x's first. Now you put in the y's. So I put in the 1y and the 8. And here it's looking a little bit nicer already, right? So let's simplify this. What's 4 minus 9? Isn't that -5. And this 1 minus 8 right here, isn't that just -7? So now it's slowly becoming simpler. Now -5 squared, we're dealing with what's inside the square root. Let's leave the square root to last. -5 squared, remember the just the parentheses, now we're doing the exponents. That's going to be 25. And -7 squared, that's going to be a positive 49. Now I want to pause right here. I want to point out to you, this is why the order didn't matter. Because if I had 9 minus 4 and I got 5 squared, that would still be 25. If I had 8 minus 1, that'd be 7 squared, and that would still be 49. Now I'm going to add what's on the inside, because I can't square root this individually. Don't do that. Do not do the square root of 5 and the square root of 49. You cannot do that. That is an illegal move. Bad. All right, so square root of 25 plus 49, that's going to be square root of 74. And that still doesn't really tell us the distance, so just put in your calculator, round to the nearest tenth, and you get about 8.6. So I know the distance between 4.1 and 9.8 is 8.6. Let's go ahead and do one more example, okay? Right here. Let's find the length of this line, the distance between these 2 points. So we're going to use the distance formula here for sure, right? And I should always keep track of what these points are, so let's mark them down. This one's -5, 5, and the second one is 1, -2. Now I'm going to put them in there. So x2, doesn't matter if you choose the first x value or the second x value. I'm just going to put down -5 first and then 1. So we have -5 right here, matches up. -5 minus 1. And then the y values. Let's go ahead and just use, since it shows -5 for the first one, let's choose the matching y value for the first one over here. y2 is going to become 5. And y1 is going to become -2. Notice how I put this in parentheses, guys. This is so I keep track of this being subtraction and this being a negative number for -2. Now let's simplify it. -5 minus 1. That's going to be -6. And then 5 minus -2. That's going to be 7. So now I'm going to simplify this even further. -6 squared, that's going to be 36. And 7 squared is going to be 49. Let's add these up. 36 plus 49 is 85. And the square root of 85 ends up just being around 9.2. So if you think about it, it's not that bad, right? We did -5 minus 1, 5 minus -2. We squared a 6 and a 7. We add these two numbers up. We square rooted it. It's not bad at individual parts. It's just you have to get used to just dealing with this formula and putting in these numbers one by one. If you need any help, please stop by during office hours. Otherwise, try the few practice problems over there. Otherwise, you have a good day. Bye, guys.